Hello everybody. Today we're going to learn about electron configurations. And first, let's just start off by explaining what they are. Their purpose is to describe where electrons are in terms of energy level and orbital, as well as the number of electrons present in that orbital on that energy level. When you look at the periodic table, it looks like it's kind of divided off into sections, and it actually is. The first two families, 1A and 2A, make up family S. And helium is actually part of that. So you can think of helium as not really being here, but being here, which is why I've drawn it in. This section over here is called P. This section here is D. And this section down here is F. These sections are not arbitrary. These are specifically designed like this because the periodic table gives us information. And the information provided by these sections is where are the valence electrons in a ground state of that element. So the valence electrons of nitrogen are in p-type orbitals. The valence electrons of barium are in s-type orbitals, and so on. Now, in order to understand electron configuration, we're going to need to know some notation. Everything you see is going to have a coefficient, a letter, and an exponent. The coefficient, in this case 3, tells you the energy level of the electron, and it's equal to the rho on the periodic table. However, there are two exceptions. In the D section, the rho is -1. So if you look here at the periodic table, the fourth row, 4s, 3d, rho -1. Once we get back to P, we're back to row 4. F is the rho -2. So we look here, this is 6s, but then we go into 4f. Okay, don't forget about this F section here. Look at the numbers. 55, 56, 57, 72. Right? There's a gap because of these. Okay, now the letter will tell you the orbital type the electron is in. This is typically S, P, D, or F. And finally, the exponent, which is the number of electrons in that orbital and energy level for that element, and it's the same as the number of columns you move through on the periodic table. So let's take a look at a few examples. The first is oxygen. Oxygen is right here, and if we want to write it out, we start at hydrogen, which is in row 1, S section, and I'm trying to get to oxygen. So I'm going to go through 2 columns of 1s, and then I ran out of row 1. There's nowhere else to go, so I'm going to write down 1s2. Now I'm still trying to get to oxygen, but I'm done with row 1. Let's go to row 2. Now I'm in row 2, S section, trying to get to O, so I go through 2 columns, and there's no more S. So 2s2. I'm still trying to get to oxygen, still in the second row, but I ran out of S, so I come over here to section P, and I go in 1, 2, 3, 4 rows, and so 2p4. And that's the entire electron configuration for oxygen. And what this tells you is that on the first energy level, in an s-type orbital, there are 2 electrons. On the second energy level, in an s-type orbital, there are 2 electrons. And also on the second energy level, but in the p-type orbital, there are 4 electrons in oxygen. Now let's take a look at aluminum. Aluminum is here, so let's try to get there. 1s2, 2s2, 2p6 all the way through, 3s2, and then finally 3p1. 1s2, 2s2, 2p6, 3s2, 3p1. Now titanium. Titanium is here. This is kind of far down the periodic table. Let's go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now remember, D goes down by 1, 3d2. 3s2, sorry about that, 3s, 3p6, 4s2, 3d2. Okay, now what we've been doing is called the full electron configuration. And the full electron configuration is informative, but it's also tedious and can take a long time, especially if you're going to do an element that's low on the periodic table. So there is another way to do this, which is called the noble gas method. And the way to do this is, instead of starting from hydrogen, start from an element in family 8A. Usually we exclude helium because it's very small, it doesn't really save you much time, and we exclude OG because there's nowhere to go from there as far as we know. So we're going to focus on these 5 elements here. Start there and then get to the element in question. Our first example, chlorine. Let's take a look. Chlorine is here, element 17, and the closest noble gas to chlorine that isn't larger, because we can't go past chlorine, is neon. So we're going to start at neon and just continue from there. 3s2, 3p5. And how you write this is by putting a bracket, the noble gas you started from, and then just continue. Alright. Lead is down here. Why don't you try pause the video and then unpause and find out if you're right. For lead, we're going to start at neon and then work our way forward, but do not forget about F. Between 6s and 5d there is 4f. So neon, xenon, and then 6s2, 4f14, 5d10, 6p2. Finally, let's try calcium. Feel free to pause the video and try on your own. And let's find out if you're right. Calcium's here. Closest noble gas is argon. And from argon, all we have to do is go 4s2. My recommendation is to just keep trying this over and over with different elements until it feels good and until you're confident. But I hope this helped. Have a wonderful day.